Hello, and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 2nd, 2025. Alright, we're kicking things off with a fascinating ICLR conference paper published just over 3 months ago on January 22nd, titled Knowledge Entropy Decay During Language Model Pre-Training Hinders New Knowledge Acquisition. This paper looks into how pre-training affects a model's ability to learn new information, introducing a concept called knowledge entropy to understand why later models sometimes struggle. Okay, Figure 1 here provides a great illustration of the core findings. It shows how the memory coefficients within the feed-forward layers, they become sparser as pre-training goes on. You can see this decrease visually, leading to a drop in that knowledge entropy metric. And crucially, this lower entropy later on correlates with poorer knowledge acquisition and increased forgetting when the model tries to learn new things continually. It's a clear trade-off, shown over pre-training time. Building on that idea, Figure 2 here quantifies this knowledge entropy decay. You can see entropy plotted against the percentage of pre-training steps for both the OLMO 1B and 7B models. Well, it clearly shows a consistent downward trend for both model sizes as pre-training advances. This really reinforces that observation. The model relies on fewer memory sources over time, impacting later knowledge acquisition. Okay, Figure 4 then directly links this entropy decay to how well models learn continually. Part A plots knowledge acquisition and forgetting against pre-training progress, showing acquisition drops while forgetting rises for later stages, both for the 1B and 7B models. It strongly suggests that lower entropy, seen in later pre-training, hinders the model's ability to integrate and retain new information effectively when learning continually. So, following that observation, the researchers tested their hypothesis with an intervention shown here in Figure 5. They essentially tried to resuscitate inactive memory vectors in those late-stage, low-entropy models. And Part A shows, well, as they amplified these vectors more, knowledge acquisition improved quite a bit, while forgetting decreased compared to the original. This strongly supports their view that activating more memory pathways helps overcome the limitations seen earlier. Alright, looking further, these plots compare knowledge entropy and knowledge acquisition rates again, this time for both the OLMO 1B and Pythia 1.4B models across pre-training stages. You can see how entropy, the black line, trends downwards over process tokens for both. Well, the blue line, knowledge acquisition, also tends to decrease overall, particularly later on. It really confirms that drop in entropy seems linked to a reduced capacity for learning new things effectively. Following up on that intervention idea, Figure 16 gives us a broader view across different pre-training stages. Part A compares acquisition and forgetting rates for the original model shown dashed versus the resuscitated ones shown solid. Well, resuscitation pretty clearly boosts acquisition and lowers forgetting. And then Part B looks at task performance, showing similar gains for the knowledge probe and downstream tasks with resuscitation, particularly for later models. This really backs up the resuscitation approach. So to wrap things up, the main takeaway here is that this knowledge entropy decay during pre-training really seems to hinder a model's later ability to learn new things. The researchers showed a strong correlation, and importantly, their resuscitation method suggests activating more memory pathways can counteract this effect. Well, that's all the time we have for this AI Research Roundup. Thanks for tuning in, and see you next time.